So a little background, I've been working at Mozilla for 4.5 years now. These days I'm mostly focused on building security and privacy features. And a big part of that for me has been developing the Firefox OS security model. So this is probably going to be a pretty dense presentation because, I mean, in OS, you cover a lot of stuff, right? So I'll jump right in. Something we started with when we were talking about Firefox OS are, what are the principles, right? What are the most important things we want to design into the system from the beginning? And then how do we determine that we actually met our goals? So we said, obviously, we want to protect the OS from malicious apps or compromised apps. We want to protect apps from each other because otherwise developers have to do a whole lot of work. And we only want to share the user's private data with user consent. So the user has to be involved in decisions that impact their data. Some quick definitions. So Firefox OS is abbreviated to FFOS. And also, if you've heard of BDG, that was sort of our internal code name for what became Firefox OS. So if you're confused, that's all the same thing. So Firefox OS consists of a stack of layers. Like any true OS, it's actually a bunch of different stuff. So underlying everything is what we call GONC, which is on the basic Linux operating system and all the hardware abstraction. So it's what takes care of the radio interfaces, the video, the audio, storage, USB, Bluetooth, all the low-level stuff. On top of that is Gecko, which is the core runtime that drives Firefox, Thunderbird, Fennec. Gaia is what we call our UI layer. So it's all the visible UI. It's all CSS and JavaScript, HTML. On top of it are a bunch of apps. And apps are all, once again, CSS, HTML, and JavaScript. So Gaia is the user interface for the Firefox OS. It's also the interface model. It's what all apps go through when they talk to the user. Like dialogues are all in Gaia, for example, system dialogues, permission dialogues, et cetera. As part of Gaia, you have a bunch of apps. These are built exactly the same way that third-party apps are built. So the system app, the home screen app, all core apps, dialer, SMS, email, camera, music, et cetera, are all written in CSS, HTML, and JavaScript. The only way they talk to the OS is through well-defined APIs. Right? So Gecko supports a set of APIs that exposes to different classes of applications. That is the only way any app can talk to the OS. And in this model, obviously we support third-party apps. So developers can write apps and install apps, and they are essentially, other than the permission bits, are exactly the same as the apps bundle on the phone. So below Gaia is Gecko, right? Gecko is the engine. And when we say Gecko, it is exactly the same engine we are putting into Firefox. So a lot of the stuff that we're building in Firefox OS is actually in core Gecko. And there's exactly the same code that we ship with Firefox Desktop, that we ship with Firefox Mobile, and that we ship in Thunderbird and other projects that use Gecko. So we're not branching Gecko, we're not creating a whole new platform for Firefox OS. We're actually reusing what we have and extending it to support this layer. So this includes all of the HTML, CSS, JavaScript engines, all the OS abstraction stuff that I mentioned earlier, like web APIs. When we think about developing a web API to expose access to contacts, for example, or for geolocation, or a bunch of other APIs I'll go into, when we think of that, we think of how to do that across the whole stack. We think about, well, if we're going to develop a context API, how does it behave on mobile? How does it behave on desktop? How does it behave on Android, where we have Firefox for Android? So I mentioned already GONC is the very lowest layer, right? This is all the hardware abstraction. It's a Linux kernel. It's mostly existing open source software that we're using. We're not inventing, we're not writing a whole new kernel, we're not writing a whole new abstraction layer. There's no need to. And so when you think of GONC in our model, it's the underlying OS that is targeted by Gecko, right? So you can build Gecko for Mac OS, you can build for OS X, right? You can build Gecko for Windows, different versions of Windows. You can build it for Android, which is what Fennec does on Android. And you can now build it for Gonk. And I mean, I'll go into a lot of details about third-party apps, but as I mentioned, they're all the same. They're all CSS, HTML, and JavaScript. So the types of apps in the world, right? If you think of the kinds of applications that exist, there's websites. Websites really are applications now. Like whether it's Gmail or Groupon or Airbnb or whatever, they're complex, they're applications. They happen to be hosted on a server, but a lot of the code when it runs on your client. It just gets not installed, but it gets delivered dynamically every time you visit the site. A lot of it runs on the client, a lot of it runs on the server. And so it's not a stretch to bookmark one of those things and say, well, now you're an application on my device. And then it's not much of a stretch to take some of that code that would normally be delivered from the server every time and persist it locally on your device. So you don't have to go refetch the same interface over and over again. It's basically caching, it's just explicit caching with guarantees that that content will be there when you come back. And then there's no reason you can't install those apps on your computer as well and use them, right? Exactly the same application, the same language, the same content. So this has a picture of a motorcycle because Ducatis are cool, just in case you're wondering. No other reason. But when we're developing applications, we want those applications to run on Firefox OS. We want them to run in WebRT, which is our runtime for Android. So if you get an app for BDG and you have an Android phone, you should be able to run the same app on your Android phone when you have WebRT installed. And for desktop, right, run that same app in Firefox on your desktop. Why not? So for Firefox OS and our app platform, there's basically, we think of 4 kinds of applications, right? One, like I said, is just web content. A website running in your browser is an application. It doesn't persist, but if you take an application that's on a website and bookmark it to your home page, as far as the user or the device is concerned, it's an application now, even though really it's just a link to a website. So the next type of application is a website where the developer of the website has explicitly chosen to have it be treated as an application. Right? In our case, in our model, all it is really creating a manifest. The manifest is a file that points to something that describes the location of an application. The next one is what we're calling a privileged app. And so privileged apps are more similar to what you're used to, for example, with existing mobile operating systems. So it's an explicit bundle of stuff, right? It has access to more APIs, it has code signing, it has certain guarantees and properties that the web in general doesn't have. Because the web in general doesn't do really the world's best job about preventing code injection, for example. By default, it's pretty easy, right? XSS is just code injection. We also have certified apps. Certified apps are core parts of the operating system that are necessary for its correct functioning. So to go a little deeper, when we think of designing web APIs, we think of designing each API in a way that can be exposed as much as possible to untrusted content, right? So say we want to design an API for having access to your location or your camera or whatever. We think first, how could we safely expose this to web content? And then, there are some properties about that are interesting. For example, for a camera, you might want to expose it to web content, but it might have to be opt-in for every use. Right? You may not want to persist the ability for an arbitrary website to have access to your camera every time it gets loaded in some iframe because maybe that's not really a great model. But, so you say, for websites, maybe we'll expose camera access only through some explicit user opt-in every time. But maybe if it's going to be a different kind of application, maybe have a different access model to the camera. And I'll go into that in a moment. So, for example, web content, by default, we don't remember decisions you make. If you go to a website and you want to give it your location or you want to give it access to your camera or your context, that decision is not persisted. So next time you go back to that site, you'll have to ask you again if it wants to have access to your camera, your contacts, or your location. User can override that, but that's the default state. When we take a website and turn it into an installed application, we don't really want to change those security properties because the underlying threat model hasn't really changed, right? Like that site could still have XSS bugs. It could still be delivered over plain text. You could have server-side injection issues and other crazy stuff. I mean, the server could just be really poorly configured and be easily owned. Anybody who owns the server obviously then owns the application. So when we make a website an application, we don't grant it much additional privilege. We don't really, all we do is we give it a little bit of UI candy, right? We can say you can go full screen without asking because the user has chosen to install you as an application, expects you to essentially be full screen. And we give you the ability to store a bit more data than you normally would for a random website. Because a random website, like if you just visit some website, you don't really want it to store a bunch of data. But if you've chosen to install something, you've sort of implied that this is something you want to keep using and you are willing to grant it a little bit more leeway in storage. So it can access the same thing that regular websites can access. It can request actions to location, sensor APIs, alarm API, FM radio. So privileged applications are different. Privileged applications come in a zip file. They have their own scheme, app:scheme. They have a content security policy. So if you haven't heard of content security policy, you should read up on it. It's something that we came up with essentially for its core purpose was to address code injection attacks. So it's a way for a developer to declaratively define a policy that controls where code can come from, that disables inline script, disables or restricts loading of script files from only specific locations. So we use this in our app model to essentially change the properties of privileged applications to prevent dynamic code generation. So what happens is that you can load JavaScript from assets that came in the zip file, basically. But if you try to do a script source equals from another server, it won't work. If you try to do an eval of arbitrary data, it won't work. Windows set timeout won't work. A new function won't work. And obviously this disrupts some patterns people are used to in development, but we have a set of documentation we're building that demonstrates how to work around it. So these are not insurmountable issues. But it gives you some really nice properties. You can now say that the code that is running in this application is definitely the code that came in the zip file. That was definitely the same code that we reviewed and approved in the App Store. And so because of that, you can grant it some more privilege because if the user makes a trust decision to trust this particular application with access to this API, you know next time you run the application, you're running exactly the same code you ran before. And that code is not trivial to inject code into, so therefore there isn't some other third-party code running inside of it you can't trust. So this means that they can have access, persistent access to higher risk APIs like Alarm API. They can do TCP raw sockets, have persistent access to Contacts API, Device Storage API, Browser API, which I'll go into in a bit, Wi-Fi Information API. And there's also detail about how these are made available to apps that I'll go to in a few slides because it's not that every app just has access to all these things. So certified apps are really a very small set of apps. These are things that are essential to the operating system's correct functioning. So it's stuff like a dialer app. It is the SMS app. It is the settings app. It is the contacts app. These are things that need to work, and they need certain APIs in order for the device to work. So we don't ask the user. We don't prompt the user about whether or not a certified application should have access to the APIs that it needs. Because, for example, if you ask the user whether the settings app should have access to the settings API and they say no, you now have a broken device. If you ask the user whether the phone app should have access to telephony, you now have a broken telephone if they say no. So these are things that don't ask for permission. which is also why this is a very small set of apps. We do not want this to be a common use case. This is only for things that are essential to device correct functioning. And so a lot of them, you can see that. It's the ability to launch and manage background services. It's direct access to the SMS API, to the telephony API, Bluetooth, connection settings, power management, et cetera, et cetera, et cetera. So a word about how data is managed. So each application has its own data store. This includes cookies, right? So this has some nice properties. One of them is that we can keep track of all the data that the app creates and writes to the device. So that means when you want to either delete all that data or delete the application, we can guarantee we can delete all the corresponding data that the app created. It also means that cookies are separate from app to app. So they do not share the one cookie store. So an app that loads an iframe from site A is going to have a different set of cookies than a different app that loads an iframe from site A. This is, it's a decision that we made. It's a design decision. We decided to favor privacy over use cases that would maybe benefit from having a shared cookie store. But then those in turn result in commingling that makes it impossible to actually tell what app wrote what cookies to disk when you want to delete an app. So let's talk about how apps are launched in this device. So apps can be started only a limited number of ways. They can be started by the user directly by clicking on an app icon. They can be launched by the system app. It's one of the privileged APIs, the certified APIs that the system app has access to. They can be launched by web activities, alarm API, notification API. So web activities, which I think I have a couple more slides on later, but web activities are ways that apps can opt into handling certain things, right? So an app can say, I handle PDFs. And if you click on a PDF and an app says, I have this PDF, but I don't do PDF, I want this to open this PDF in something, it'll fire a web activity saying, open a PDF. And apps on the device that are registered to open PDFs through web activities can then say, oh, I'll take care of that, right? So it's a way of launching an app with a specific piece of data. But an app has to choose to participate in that model and to choose to consume those specific kinds of activities. Alarm API is maybe a bit of a misnomer. Alarm API is not like an alarm clock API. Alarm API is a way for an app to say, wake me up in a certain time because I have to do something. Right? So this is a way an app can do polling. It can decide to wake itself up every hour to do something and go back to sleep. But that is a way of launching an app, right? The app is choosing to be launched at a certain time. A notification API is something similar in the sense that you might have a notification that comes in about a push notification, right? So your app has received a message and it goes into the notification bar and the user says, oh, I want to go take care of this. And they click on that notification in the notification bar. That'll launch the app to handle that notification. Two ways you can't launch an application. One app cannot launch another app. So app A can't say, I'm going to go launch app B directly. Only through web activities if they know that app B consumes a certain activity they want to pass to it. But they can't launch an app directly. And even though it's web content, you can't actually launch another app. So you can't by framing it. So you can't say iframe source equals app : / insert app ID here. We don't support that. And apps, closing them is pretty simple. You can either close them directly using a task list, or the OS will also kill apps as it sees fit as resources become scarce. So the way, to get a little deeper, so the way that we actually implement this is that the system app launches apps inside of what we call a Mozapp frame. So only the system app can create these kinds of iframes. It creates a separate data jar. So what essentially it means is that there's, traditionally in the browser, an app is defined by an origin, by a domain. We've extended that model to say that not only can an origin create a domain, but also an app ID can create a domain. So when a system app creates this iframe, a Moz app iframe, it is basically creating a new domain, a new context for an app. And apps run inside of a content process, right? They're not actually privileged processes. And the privileges those processes have are commensurate to the APIs they have access to, but no more. We also have this other second kind of special iframe. It's called a Moz browser. So this is for apps that intend to behave like a browser, right? They want to navigate the content. They want to probably provide or display lots of different kinds of content to the user that may not be really designed, or that content may not be designed to be interacting with that app specifically. So this allows the app using Moz browser to have a little more control than normally would over an iframe. In an iframe, normally you can't see anything that's happening. It's opaque. In this case, there's a couple of changes. One is that the child, when it asks for its window.top, gets its own window back. It doesn't get the parent window, which is normally what happens in the browser. If you have it in the browser, you have a window that creates an iframe, and that iframe wants to know what the window.top is, it'll actually get the parent. In this case, as far as the child is concerned, it is the top. He has no idea that it's framed by something. It also allows that the parent to have a little more visibility into what's happening, so it can handle events about reloading, redirecting, et cetera, because that's what a browser needs to do, is needs to communicate back to the user certain browser state related to what the child process or the child frame is doing. So this is a pretty bad graphic attempting to sort of display this. Imagine that the outer border here, outer window, is a system app, right? And so it's decided to launch an actual third-party app called cats.com. And that embeds an iframe that also loads stuff from cats.com. In this case, they have the same cookie store because they're in the same app in the same domain. But if in the turn that actually uses a Moz browser iframe, the Moz browser, because it behaves like a browser, will create a separate data jar for that. So the cookies and all the data that is stored will be treated separately. So we spent probably the bulk of the time, and one thing that was interesting about this process is my goal was to design this in the public domain. So if you want to know why we came to the decisions that we came to about the camera API, for example, there is a 120 email thread you can read on Mozilla Dev B2G about how we came to decisions around the camera permission model. We spent a lot of time designing and discussing how to build the permission model because that is really what manifests the security model to most people. So if you think about how an app asks for permissions, there's a couple hard properties about this. By hard, I mean they're not flexible, that they need to be enforced. So all permissions, all API permissions an app needs need to be declared in the manifest. If an app asks for permission that's not declared in the manifest, it will always be denied and the user will never be prompted for it. Part of the value there is that if you as a reviewer or as a user want to understand what an app could possibly do, you can start just by looking in the manifest. And know that if it's not in the manifest, the app can't do it and can't ask for it. And inside of that list of permissions in the manifest, they're basically, depending on the type of application you're looking at, there's two kinds of permissions. There's implicit and explicit. All that really means is whether or not they're prompted for. Explicit permissions require explicit user consent before they're granted. Implicit ones don't. So an implicit permission, if an app has an implicit permission in its manifest and it's being gone through the appropriate approval process for that type of application, then it will be granted at runtime. If it's an explicit type of permission, which are most privacy-sensitive permissions, then it'll have to be in the manifest and it'll have to be approved by the reviewer, the application will be, and it has to be granted by the user at runtime. So one thing that might be different from people are used to, well actually it's not different from the iOS model, is that the permissions are at time of use. So if an app needs 3 or 4 permissions that require prompting for, the user will not see a 3 or 4 permission prompts when they first launch the app, because odds are it doesn't need all those right away. We only prompt for permissions when the app actually tries to use the corresponding API, right? So if you launch an app, it's like a social app, let's say, and say this app wants to have access, wants to have access to your camera to take pictures of stuff that you're, whatever you're eating for lunch, right? Maybe wants geolocation to find you on the map, and maybe wants access to your contacts so you can share where you are with your friends. It won't do all that when it first launches, right? Only when you want to do those activities will you get a prompt. And the way that the application prompts you is it doesn't actually say, ask for this permission. It just simply tries to use the API. So once an app asks for your location, then we handle the permission prompt. And the developer doesn't have to worry about it. So this is essentially not the final UX because it's a little rough, but this is the UX for permission prompts, what it looks like. And you can see is that one difference between privileged apps and non-privileged applications is that remember my choice default is different. For privileged apps, because the code can't change without being re-reviewed, we're pretty confident that if a user decides to grant an application access to something, it will make that decision most likely again and again. And what we don't want with a prompting model is to always keep asking the user repeatedly the same question without them being able to basically say, don't ask me again, just remember my decision. You can always change this later. So if you make the wrong decision and you say, grant access to this thing and remember my choice, and you decide a week later, like, that's not what I want, you can just go change it. But the main difference between privileged apps and non-privileged apps is that privileged apps by default remember their permission responses. So once again, if you change your mind, if you grant the wrong permission to an app or you just don't want to have access anymore, then you can just go into the settings app, find the corresponding app, and change the permissions to what you want. Or just simply inspect to see what the permissions granted to that application are. We also try to do, as much as we can, persistent background ambient notifications around permission usage. So if an application is using your location, you'll get this icon in the, I mean, this is not that new, right? This is in the URL bar, you get a notification that's using your location. But it's true for camera and a couple other APIs. So you can always know if you're not sure, there's a reminder there that this app is using this API that you previously granted access to. So I touched on web activities before. This is actually how a lot of apps will get access when they don't have a lot of privilege, right? So if you are the social app I mentioned before, and you want to take a picture of whatever you're having for lunch, right? Yeah, you could implement a whole camera app inside your social app. Probably a better thing to do is just simply fire web activity that says, please go get me a picture. Right, so this is an example of how web activities work, is that you would have the default camera app would be registered as a handler for the take a picture activity, or give me a picture activity. And then the social app would simply go, I want a picture, fire web activity, that would start the camera app. The user will go take a picture with that camera app, and that picture will be then handed back to the application that made the request in the first place. What's nice about that is that the developer doesn't have to create a camera app inside of the social app. You don't have to grant that app camera access, right? If it fires off a web activity event for a camera and you don't want to take a picture, you just cancel out of there and you can't take a picture. So it's a very simple model. It enables a lot of functionality for a lot of apps without having to worry about granting them direct access to those APIs. So we did think a lot about privacy when developing this model, right? So you have do not track as an option there. But the primary thing is that we always ask you for access to privacy-sensitive APIs. So every app that wants to have access to your location, to your contacts, to your camera, to a few other APIs, unless they're a certified app, always has to ask the user. So there's no surprises there, right? if an app gets access to your contacts, it should be only because you granted it access to your contacts at some point. And as part of that, you can always change those settings. You can always go clear the data for an application, and you can always, the data is always erased when you uninstall the application as well. As part of any OS, you have to figure out how to protect the OS as well. So we've done it a couple of ways. So if you look at the boot sequence, just to give you guys a sort of a high-level overview, when it boots up, you have the Linux startup, right? And then you have the Gecko starts, which then starts shell.zool, which is a container essentially for what loads the Gaia system app, which then loads the home screen app, which then registers the core system installed apps that handle stuff like web activities for and event activities for, or system activities for SMS handling, telephone handling, radio state, Wi-Fi, and a bunch of other core system operations. What this looks like in code is sort of basically like a window, which is the Gecko Chrome shell.zool. Inside that is an iframe that is a system app. Inside of that is an iframe, which is a home screen app, and so forth. So if you wanted to visually represent it, it looks something like this. We have in Firefox a way of actually visually 3D-ifying layout, right? Like window layout. And that gives you an idea of how this actually builds in memory. So the way we look at protecting apps from each other is each app runs in its own content process, right? So it means they can't see each other's data or cookies. They can't see it at a process level. An app can't launch or frame another app. And the process permissions are equivalent to the manifest permissions, which means that if your app doesn't need access to like camera, the process itself has no access to the camera anyway. So the way apps talk to the OS is over IPC, right? So each app process is a low rights process. If it wants to have access to much of anything, it has to go ask Gecko for it. And it does it through this basically a pipe, an IPC channel. And, well, that's it. There's an OS update model, right? And the update model is actually different depending on whether you're talking about Gonk versus Gecko versus applications. So the underlying OS, the Linux layer, is basically updated over OTA updates, over-the-air updates, or USB, right? You can plug it into your computer and flash it. Gecko and Gaia are actually kind of the same. They're basically, they follow our normal release process. The way we release Firefox is how we release Gecko updates, how we release Firefox OS updates. And likewise, you can either do over-the-air updates, which is sort of an auto update, or you can have an image on your device that you flash directly, or on your computer you flash to the device. And app updates are handled individually, which is to say that because apps don't actually have to come from a certain app store, each app can be responsible for its own update process. The mechanism is the same, but they can define where the updates are hosted and the notification mechanism. So that's it at a high level. I want to give lots of time for questions and QA, because I know this is kind of a crazily complex model, and I've blown through it pretty quickly. Okay. I got most except the very last part. Okay, yeah. So we've taken a different approach there. Apps can't change the policy. So the policy for privileged apps and certified apps is actually enforced by Gecko, and it's not modifiable by the app. We have a bug that we're working on, which is the ability for an app to specify its own CSP policy, but that follows normal CSP policy intersection rules, which is actually means it can only be further restrictive, right? So right now, if you have two CSP policies somehow in the browser, you can only, well, you can only have the intersection of their privileges, right, or the union of their restrictions, however you want to think about it. Well, yes, that's what I'm saying. We actually have a minimum CSP that prevents any dynamic code generation and restricts code loading only from the app package. And the developer can't loosen that. Yeah, so Mozilla's had a project called PDF.js for some time. It's actually, I mean, it's currently available as an extension. Eventually, we're going to build it into the browser once it's fully baked. But it's a way of rendering PDF entirely in JavaScript. And there's an implementation of that in B2G, in Firefox OS, that is registered as a PDF handler. So if you hit a PDF file, basically the PDF.js has already registered itself for the PDF handling activity. It is possible, and the user would then be presented with a choice. Okay. Come on.
A lot of problems with the Android apps is, like, for example, the makers like Samsung install these insanely highly privileged applications that totally defeat the entire permission and security model. How do you see Firefox OS protecting against carriers and makers doing these types of activities?
Yeah, it's an excellent question. So the answer is probably going to seem a little obscure, but I think it's actually the right one. It's actually a question of branding. Right, so if we're going to ship something called a Firefox OS device, we want to make sure that it manifests our beliefs, right? Our brand that we want to project to the user, which is not one with a ton of crap that the user doesn't want and can't delete. So anything that we want to have branded as a Firefox OS device is the user is going to be always basically top of the food chain. So they have the ability to uninstall anything other than core, critical, privileged, certified applications that are necessary for OS operation. So there's a bunch of stuff on there the user doesn't want, they can just delete it. We actually don't want a ton of random junk on there to begin with because it's just not a great experience. That said, it's an open source project, right? So if somebody wants to take the code and implement something based upon it and not use any of our branding, like that's open source, right? And they might do that, but then it's not going to be called a Firefox phone.
I have a question about the permission model. Mm-hmm. So when you say, for instance, the app requests internet access, if I say don't allow, will the app just say no and exit, or will it think?
No, yeah, that's a good question. So there's the model for developers. The model for developers is that they need to handle the case that every explicit permission may be denied by the user, and they need to continue running. So we do not want people to be browbeaten into granting permission, saying, well, you give me this permission, I'm going to quit, right? The way we handle that is for privileged applications, they need to go through a review process. And we find applications that try to bully the user into saying yes, well, we will not approve them. And so if we don't approve them, you end up with an app that can't do much anyway. Right, because they can't be a privileged application, so they don't have access to very interesting APIs, and therefore the user just will not probably even install
them. Along that same line, so what happens if you want to, let's say an application is requesting like internet access or access to a third party, is it going to display the site that it's trying to access? My concern here is that a lot of these applications have this basically adware or spyware or whatever is installed, you granted permission for maybe internet access, but it's also using that same channel or that same permission to send data to a third party for whatever reason.
Yeah, so we face some tricky choices when trying to decide how to implement this. So well, I'll take blame for that. I was actually pretty explicit that I don't want to have a huge set of permissions. And I don't want to bug people about this is trying to do this very specific thing to this particular site, because the sheer number of permissions will just cause people to totally tune out and not really treat them as decisions anymore. So we don't prompt for internet access in general, for example. Like that's not a permission we think is meaningful in a web, because the web is, it is what it is, but the nature of the web is that communication patterns are essentially managed by sites opting into communicating with each other, not the user saying, I'm going to allow this site to talk to that site, right? Because like cognitively, that's impossible for users to manage. So we try to only ask for things that are really privacy impactful. And for the rest of the things, we rely on the review process, right? So unprivileged applications, like I said, are really just like websites. So it's the same model, right? They don't ask for a lot, but they can't do much either. Now, if they want to do more, then they have to go through a different model that requires an approval process, a review process. And we rely on the review process to manage the risk from a low-level security standpoint, right? So if an app wants to have access to like raw socket, it needs to be a privileged app. We're going to take a look at that, and it's like, why are you using raw socket? Is it really responsible for you to use this, or are you just kind of using it for something really sketchy, in which case you're not going to be approved, so you won't have that privilege. And then when we ask the user, when I only ask the user for privacy impactful things where they have a chance of actually understanding what it's about. So one thing we do is we have the ability for the developer, and we actually encourage them to use this, to specify what we call as an intended usage. So when I say I need access to your camera, like you can actually say I need access to your camera for the purposes of taking a picture of your avatar for the social network or your whatever, right? And that's part of the review process. So when you say I want to have access to the camera for the purpose of, we try to actually make sure that that is actually what you're using it for. And then the communication to the user is a lot more meaningful, because you're not just asking an API access question anymore, you're actually asking about access to information that the user is probably in a better position to decide about.
Thank you, and I have one final question. Have you thought about how that review process is going to scale? Yes, so there's a couple of characteristics. One is that we don't want to have a ton of these requests, right? Two is that they're at time of use, and so it's unlikely that you're going to hit these over and over and over again at the same time, right? I would say that because you have the ability to persist a decision, it gives a lot more flexibility to the user to decide that, yes, this is a decision I want to persist or not, right? Like I've had an iPhone for a while, and in San Francisco, there's a very simple app called the Nextbus app. It's a web-based app. All it tells you is, like, what buses are going to be showing up soon for your location. So it needs your geolocation to do that. And every time I run it, like, it always asks me if it's okay to have access to your location. I'm like, the only reason I run this app is to have access to my location to tell me what buses are coming. Like, I will never say no to that. So don't ask me. So like, we've built in these bits of flexibility where the user can make a decision, and they can say, for this thing, always allow. For this thing, always deny. And for this thing, ask me. And so there will be some apps, but still, like if you look at the total number of permission requests most apps will make, like even very complex ones, you're talking about maybe like 3 over the whole, all the code paths in the app, right? Or 4 at most. So we don't ask for a lot of stuff, I think. So I don't know what order there, then there, I guess. Whoever gets the microphone.
Okay, I've got a microphone, so I win. The last question I had was specifically around the iframe and the Moz browser frame that you describe. So you said permissions, that, you know, it's the web and everything like that. So have you thought about where sites literally embed other sites and get the user to authenticate and then, for example, steal the cookie? Because at the moment seems there's nothing stopping that. Someone like reskinning a fake browser, for example, and then having access.
So you don't have access to cookies, for example.
In either case, they're not stored in some addressable local storage mechanism within the app.
That's correct. So we still manage all the cookie, we still manage the cookies, right? So you already have this problem in the browser, right? Like the browser, you have the window.top, right, is the what you see in the URL bar. That can embed many iframes.
Sure.
And it has no access to anything or the cookies in that iframe because that is part of the principle. And we look at whether does the code in principle A have access to code in principle B or window B, then we look at the principles, compare them if they're the same, and deny it if they're not. So that still holds true.
So in the Moz browser frame scenario, do you honor the site's, for example, framing policy? So I forget the exact HTTP header that restricts whether or not they can be framed.
X-frame options?
Yeah, that's it. Thank you.
Yeah, so that's a good question. So let me put it this way. The only purpose, so Moz browser is actually a privileged API for this reason, because we want to make sure it's used responsibly. And the only purpose for it is to be a generic browser type application, right? Either because your app is a browser or your app is some sort of feed consuming thing that then displays things in sort of a browser.
Is it clickjackable though, from the parent app?
I'm not sure if it is because the parent doesn't have much control over the layout, right? I mean, I'd have to look at it, but the reason, the short answer is it's a privileged API exactly for that reason, because we don't want to change the security contract between the parent and the child without having oversight over that, right? And if we start seeing people doing sketchy things, we're going to be able to see it in the review process and try to figure out why they're doing that and then dig into it.
So when a developer submits an app through the App Store or whatever would be, how do you check that app, and how do you make sure that that app is not malicious, resulting having some malicious files, like malicious app in the App Store?
Sure. So we're still refining the review guidelines, but the short answer is actually we've been doing this for quite a long time for extensions, right? So we have an extension ecosystem, and everything that we host that's available for download is reviewed, and it's reviewed a couple different ways. There's a bunch of like tools that we use, we run against them. So we have third-party actually antivirus companies that go scan our repo and tell us if there's anything in there that's sketchy, like malware. We have a bunch of our own scanning stuff that runs mostly for looking for either known bad or malicious patterns of coding. And then there's actual physical review, like people actually go look at the code. The downside of that, the expensive part of that right now is there's no actual manifest with permissions, right? So everything's kind of Chrome privileged in our current extension model. And that is very risky because you just have to review all the code. Now, with our app model, what happens is you first start looking at the privileges, right? If you don't see any scary privileges, like it doesn't ask for anything interesting, then all you have to look for is sort of typical phishing and just general quality of experience issues. If you do see specific APIs that are potentially dangerous, you can focus on those parts of the code for review. So it's the same process we use for extensions, but made way more efficient by the fact that we can actually reliably predict application behavior.
Thank you.
Sure.
More questions?
Oh, in the back.
Just to play devil's advocate, I think that the model.
No devils allowed in here.
I think the model you have, where basically each app is protected from each other, is really great. But what about the user experience that I think is becoming more and more common on the web, where you're using a single account to sign into many services, where you can sign into different websites with your Facebook account or with your Google account, and where you would have then for the user an application that if they were signing in through a browser, they would have a single click, but in Firefox OS, they would have to re-authenticate with those credentials for each individual app. Well, what's your response to developers who kind of like that user experience?
Sure, so that's a good question. So that's one of the trade-offs we had to consider in designing sort of the data management model, right? We sort of went the more privacy-sensitive side for now, but I think what's pretty reasonable is in the future having explicit APIs to handle those specific cases, right? So having apps opt into the model where they're willing to share, you know, some set of tokens amongst themselves, maybe in a specific authentication store, right? And that would have functionally the same benefits without actually just starting to just shove all the cookies back into one huge cookie store.
No more questions? No more questions. Okay, so that's it. So a big applause.
Cool. Thank you.